में हो? बाद में हो क्या?
मैं दे रहा हूँ।
कोई नहीं, तो क्लास कर ले, मैं बाद में कर पाऊंगी। बता, क्लास कर ले आराम से, मैं बाद में कर दूंगी।
ओके, गुड इवनिंग बेटा। Okay, good evening, beta. Shall we start now? Okay. What do you want me to start? Yes. What motion in a plane? Okay. Let's start laws of motion. Numericals. Okay. Laws of motion, numericals, or any other thing you want. Okay. We are starting now. Let's rub this and let's start with laws of motion. I'm rubbing this and now I'm coming. 1 minute. Okay, we are starting. Let's start. First of all, laws of motion, you have your NCERT book. You take out your NCERT book. We can start questions from NCERT book and then we'll do questions from somewhere else. Okay. Shall we start now? Okay, come to the question number 36. Question number 36. Can you do this question? Question number 36. You see the question? Can you read the question? Yes. Yes. Ignore the mass of the box. So, can you do this question? Okay. Shall we do it here or not? Okay. Let's start with this. So, what are the concepts that you are going to use over here? You know what is inertial frame and non-inertial frame? What is the difference between inertial and non-inertial frame? No. First of all, you need to identify what is inertial frame, what is non-inertial frame. Then, if an object is kept in a non-inertial, what is going to happen? Whenever, let's say there is an object which is kept in a non-inertial frame, what is going to happen? See, we are having inertial frame, we have done all these things. Non-inertial frame, so what is the basic difference? Inertial frame are those frame which is non-accelerating and non-rotating. Any frame which is neither not accelerating nor rotating. That is an inertial frame. Is it okay? Any frame which is not accelerating or not rotating. So any frame which is not accelerating or not rotating is an inertial frame. And what happens in this? Newton's laws of motion are valid in this. Newton's laws of motion are valid. We don't need any correction term. And what about non-inertial frame? Any frame which is accelerated or rotated is a non-inertial frame. And if an object is kept on this non-inertial frame, it is going to experience a force which is known as pseudo force. Remember? Pseudo force or fictitious force. Okay? Or it is known as imaginary force. Why it is known as imaginary force? Because nobody is applying this pseudo force. It is just there. It is coming because of the inertia of rest or motion or of direction. So it is coming off because of the inertia. That's why we are calling it a pseudo force, fictitious force. So what is the situation over here? A truck which is moving, which is accelerating now. There is an open area on the truck and the box kept over here. What will happen? Any object which is kept on a non-inertial frame is going to experience a pseudo force. Let's see over here how it acts. And because of that pseudo force, what will happen? Let's say this is a mass over here, and this mass is accelerating in this direction. Okay, so it becomes what? This becomes a non-inertial frame, isn't it? This becomes a non-inertial frame. Suppose you are sitting in your car and the car is not moving, it is at rest, so it is an inertial frame. As soon as you start your car, you accelerate your car. Now your car is accelerating. It has become a non-inertial frame, and anything on this non-inertial frame is going to experience a pseudo force. Just suppose you accelerate your car. When you accelerate, what happens? The passenger falls backward. Why? It is coming out because of the inertia of rest. Or we can say, but its inertia of rest is okay, but we need to find that force with which we are falling back. So let's say any object which is kept over this non-inertial frame, let's say this mass. Let's say the mass of this object is capital M, the mass of this is small m. So this small m is kept over this. What will happen? It is going to experience a pseudo force in the backward direction, isn't it? Pseudo force. And what is the magnitude of this pseudo force? It will be m times a. The mass of this small object and the acceleration of this non-inertial frame. And it is going to, this much force it is going to experience in the backward direction, isn't it? And while it is going in the backward direction, friction is going to hold it, isn't it? If friction is there, it will hold. It will somehow try to oppose the motion. But if this force is more than the coefficient of friction or the friction force, then it will start accelerating in the backward direction. So this is the situation over here. We need to understand this situation, this question. Shall we come to this question? Shall I rub this part and we come to this question? Okay, I'm rubbing this and coming to this question. See, the situation is we are having a truck over here. It is just like it, they have drawn it like this truck. There's an open truck over here like this. Now what is happening? We are having a box over here on the truck, and the space is 5 meter. This distance is 5 meter. If it covers a distance of 5, while the truck is accelerating in this direction, it becomes a non-inertial frame. By the time truck reaches to some point, what will happen? There is an acceleration in the truck. This box is going to experience a pseudo force in the backward direction, although the friction is holding it. Friction is also active. So we'll draw the forces on this box. Friction is trying to oppose the motion, but the pseudo force is acting in the backward direction, which is pulling this block in the backward direction, and ultimately it will fall from here. So let's see what we are going to get. Now the acceleration is equal to 2 meter per second square. This is the acceleration of the block. This non-inertial frame. Now what happens? Draw all the forces on this block. Let's say I am drawing the block over here. Let me draw the block over here. It will be better. The block is over here. So what is the mass of the block they have given? A box of mass 40 kg. So the mass of the block is 40 kg. We can write it over here. It's 40 kg. Now let's draw all the forces over here. What will happen? It will experience a pseudo force, isn't it? It experiences a backward force, pseudo force. So what is the pseudo force? Let's say I am writing it. While the truck is moving in this direction, the box will experience a pseudo force. I am writing PFP. This is the pseudo force, and this pseudo force will be equal to what? This mass times the acceleration. Is it okay? Now what will happen at the same time? Because the force is acting, it will try to move, but the friction will act in this direction. Friction will try to stop. So what will be the net force in this direction? This will be the net force in this direction, F net, isn't it? F net, net force, we know this thing. F net is equal to mass into acceleration. I am writing it A1. Why I am writing it? Because ultimately the block is moving in this direction. Let's take the acceleration as A1. I am taking it. So I am taking this direction as positive in this case. I am taking this direction as positive and this direction as negative. So what will happen? What is the value of F net? That is the pseudo force minus friction is equal to MA1. We need to find the value of this A1. So what this value, what is the pseudo force over here? You know pseudo force is mass time acceleration. I have written over here.
Yeah.
And what is the value of friction? Friction is mu times normal reaction. You know this. What will be the normal reaction? This is mg over here, and this is the normal reaction over here on the top. So what will be the value of friction? Friction will become mu times, in place of n I can write mg. Is it clear? Any doubt? Board is visible or not?
Yes, sir.
So this friction becomes this thing. In place of friction you write mu times mg. Now what are you getting? M into A1. This is what I am getting. Now your M will get cancelled from everywhere. Now put the value of acceleration and mu times g. Okay, what they have given, what the value of mu they have given? Mu is 0.15. Mu is 0.15. And what is the value of acceleration? Acceleration we know, we have already written 2 meter per second square. 2 meter per second square. What is the value of g? What if they have given anything?
No.
We must take, okay, let's take g as 9.8 if they are not giving. Meter per second square. So this is the value of g. We'll put the value of g, mu, and what we are going to do is we are going to find the acceleration a1 over here. With this acceleration it is going in the backward direction, isn't it? Now put the value of a, which is 2 over here. Mu is how much? Mu is 0.15 into 9.8. Okay. So what ultimately we are getting? 2 minus 0.15 into 9.8. Point 0.15 into 9.8. How much we are getting? We are getting 1.47. I am getting this value as 2 minus 1.47. This is my E1. So 2 minus 1.47, how much? What is the value of this?
0.44.
Yes.
0.47.
Yes, it will be 0.53 actually. If you subtract this, you get 0.53 meter per second square. This is the value of A1. You got this thing? What we are doing? 0.53 is the acceleration. Is it okay? Now what they are asking actually, at what distance from the starting point does the box fall off? Ignore the mass. Now they are asking at what distance from the starting point. Suppose the truck is starting from this point. Truck will move to some distance. At that distance the mass will fall. So they are asking the distance covered by the truck at which the mass will fall. So how we can find this thing? We have already find that this is the acceleration. With this acceleration it will move this distance. How much is the distance? Let's start with this. For the box of mass 5 kg. No, it's 40 kg. So this box of mass 40 kg, what is going to happen? It is going to move in the backward direction. Isn't it? When it is going to move in the backward direction, what will happen? See how much distance it will move. It is having a distance of 5 meter only. So the distance will be 5 meter. Okay. The next thing is, what is the acceleration? Acceleration will be 0.53 meter per second square. Next thing हमारे पास क्या है? Next thing what we have? What is the initial velocity? Initial velocity is 0 meter per second. Okay. So what we need to find? We need to find that what is the time period. Okay. How can we find the time period? We can use the equation ut plus half a t square. We can use this equation. S is equal to ut plus half a, let's write t1 square. Now we know this initial velocity is 0. So this becomes 0. What we are left with? We are left with 0 into t plus half. A1 is how much? I'm putting my value of A1 0.53 into t square. T is how much? We don't know what is the value of t square actually. So we are interested in finding the t. And s is how much? We know the value of s. It is 5. So from here you can see t square is equal to 5 into 2 divided by 0.53. Is it okay? Or we can write it 10 by 0.53 seconds. Is it okay?
Yeah.
Now we have got the value of t square actually. We have got the value of t square. Now we need to find? This time is going to remain same, isn't it? This time is going to remain same because why this time is going to remain same? Because in this time only this truck will go from here to here, isn't it? So can we find the distance the truck moves with this acceleration with initial velocity 0? Because truck is also starting from rest, so the initial velocity of the truck will be 0. Okay. Find the value of the distance the truck is going to move. How will you find it? Let's do it. Till now you have any doubt? Till here?
Yes, sir. No.
If you are having doubt, you can ask. Okay. Let's come to the next part. See, the truck will cover some distance. What I have done from here? Let's see from here what I have done. The block is kept over this truck. Now, truck is accelerating. It's a non-inertial frame. Anything which is kept on non-inertial frame is going to experience a pseudo force. So, it will experience a backward force like this, which I am saying as pseudo force Fp. And the value of pseudo force is mass times the acceleration of the non-inertial frame. Okay, and the friction is acting in the forward direction because it will try to oppose the motion. Now friction is in this direction, pseudo force is in this direction. The net force will be in this direction only. So we know F naught is equal to mass into acceleration. This will be the acceleration of this small block A1. Now you can see F net is equal to Fp, pseudo force minus friction. Pseudo force is what? Pseudo force is this m into a. Friction is mu times mg is equal to m into a1. This is what we are getting. Now put the values over here. You can see mass will get cancelled out from here. Acceleration is 2 minus 0.15, that is the coefficient of friction, into 9.8. You are getting a1 over here. This is the acceleration with which the block is moving in the backward direction. So now for the block of mass 40 kg, what is the distance it will move? By the if it moves a distance of 5 meter, then it is going to fall because only 5 meter distance is there. So I am writing S as 5 meter. What is the acceleration it can have? It can have is 0.53 meter per second square. Now the initial velocity is how much? It is 0. Now S is equal to ut plus half a t1 square I am writing. We know the initial velocity is 0, it is starting from 0. Half a acceleration is this much, we have already found out t. Now we have find out the value of t. This is the time by which the block will fall down. Okay. In the same time we need to find how much this truck will move ahead. So let's say the truck will move ahead by a distance of S1. Okay, S1. Distance covered by the truck. Okay, so this is the distance covered by the truck. So now S1 will be equal to how much? Let's do it. What is the acceleration? Acceleration is 2 meter per second this time. So S1 is equal to u t plus half a t square. So initial velocity we know is 0. Truck is starting from 0, the t is 0, then half. How much is the acceleration? Is this. So S1 becomes how much? Into t square. In place of t square, what we have to put? We have to put this. Okay. See over here. This is the thing I'm just putting it over here. Is it okay? This 2 and 2 will get cancelled. We just have to solve this value. S1 is equal to 10 divided by 0.53. If you solve the value 10 divided by 0.53, how much you are getting? 10 divided by 0.53. I am getting 18.86 meter. Okay. 18.86 meter. This is the final answer. This is the distance by which the truck will move by the time the mass falls from the truck itself. So is there any doubt in this question now? Okay, shall we move to the, okay, you note it down if you want to, then we'll move to the next question. Okay, shall we move to the next question now? Okay, we are moving to the next question. We are moving to the next question. So what is the statement for the conservation of momentum? What is momentum and what is the statement for conservation of momentum? Define momentum and the statement for the conservation of momentum. What is momentum and what is the statement for the conservation of momentum? Yes. And what is the statement for the conservation of momentum?
Like the whole system, the mass is conserved, so initial momentum is equal to the final momentum.
No, what is the actual statement? What is the statement for the conservation? This is not the actual statement. What is the actual statement for the conservation of momentum? There is a statement for it. And there is a derivation also for it. So what is the statement I am asking, first of all? Okay, you know what is the statement for the Newton's second law of motion?
Yeah.
Tell me what is the statement for Newton's second law of motion?
Yeah. Force at a particular point at a particular instant is related to the acceleration at that particular point of instant.
Okay. So what is there any relation between the statement of Newton's second law of motion and momentum? You said nothing about the momentum and the force. What is the actual statement for Newton's second law? There is a relation between force and momentum. That is what the Newton's second law says. That relation you should know, na? This is what you are saying about acceleration, it's okay. But there is a relation for that between force and acceleration. Now, what is that relation? No, not derivation, it's a relation. Let's see what it says. The Newton's second law of motion says that the rate of change of momentum is directly proportional to the external unbalanced force. This is the actual statement. The rate of change of momentum is directly proportional to the external unbalanced force. Are you getting this thing? We say like this: the rate of change of momentum, how we can write? We can write dV by dt. The rate of change of momentum is directly proportional to the external unbalanced force. This is the actual statement, isn't it? Now, in this statement, if the external force becomes zero, if this external force becomes zero, what happens? This is zero. Now, the differentiation of dP by dt is zero. That means what? We have studied that differentiation of a constant, if let's say C is a constant, differentiation of a constant is zero. That means if differentiation of momentum, P is momentum, differentiation of P with respect to time, if differentiation of P with respect to time is zero, that means the momentum becomes constant, isn't it? It becomes constant. So momentum constant means initial momentum is equal to final momentum. Initial momentum is equal to final momentum. This is what I am getting. So when this thing is happening, now conservation of momentum says what? Conservation of momentum says if the external force on the system is zero. This is what it is saying. If the external unbalanced force on the system is zero, then the momentum of the system remains conserved. That is, initial momentum is equal to the final momentum. This is what the conservation of the momentum says. And the statement of second law of motion that also have given over here. Statement of second law of motion says that force is directly proportional to rate of change of momentum. Is it okay? Now, what does the statement of the third law of motion says? Third law of motion. What is the statement for that? And then we need to understand the friction. What are the types of friction? What is the coefficient of friction? What is the relation between angle of friction and coefficient of friction? Okay, tell me what is the Newton's third law of motion? Yes. Yes, for every action there is equal and opposite reaction, and these action and reaction are always on two different objects acting simultaneously, and the magnitude of action and reaction they are same but acting on two different objects, isn't it? Magnitude is same, the value is on two different objects. So that is what it is saying, third law of motion. Now when we come to the after this, when we come to the friction, you know, if I rub this, what are the types of friction we have studied and why they are different?
Kinetic friction and rolling friction.
Yes, if I talk about friction, what is the definition for friction? How do you define friction?
Friction is the contact force which opposes motion.
Yes, contact force which opposes the relative motion between two bodies. It opposes the relative motion between two bodies. Whenever there is a relative motion between two bodies, it will try to oppose it. That is what this friction is doing, isn't it? So now when we come to the friction, we have first of all static friction. Static friction. Static friction. Then we have kinetic friction. Static friction, kinetic friction. Then we have in between we have limiting friction. You remember?
Yeah.
What is this limiting friction?
So it's like the maximum force of friction. If we go beyond that.
Yes, it is the maximum value of static friction. Static friction, limiting friction. Then we have kinetic friction. Okay. Then we can have rolling friction. That we are not going to discuss over here. That we'll discuss later on. Rolling friction and fluid friction. These two we will discuss later on. Fluid friction. Okay, these two we will discuss later on. Right now we are concerned with static friction, static friction and kinetic friction. So why the nature of the friction is changing? When we call the friction is static and when we call the friction is kinetic, and why there is a difference?
Static friction is the force that resists immediate moving from one body to another. Which means static friction is when before you even apply the force of the on the object is the static, which does not allow you to put that force to move the kinetic friction is when the object is already in motion.
Okay. So static friction is when the object is at rest. When the object is not moving, that time the friction is static friction. And the another thing about this is a self-adjusting force. Self-adjusting force. Now self-adjusting force, what does this mean? This means that if an object is kept over here, let's say, if an object is kept over here, I am not applying any force on it and it is at rest. What is the value of friction force on it?
It's usually the force of time until a certain point.
It is equal to the force of?
The external force.
Yes. Right now I am not applying any force. Then what is the value of the friction?
Then 0.
Yes, it's 0. Now let's say if I apply a force of 10 Newton. I am applying a force of 10 Newton and still, yes, and still it is not moving. Still it is not moving. What will be the value of friction over here? Yes, it will be equal to 10 Newton. If I increase this force to 20 Newton, still it is not moving. What will be the value of friction? Yes, 20 Newton, because it is a self-adjusting force. As I increase this applied force, the friction force will also increase itself. If I apply a force of, let's say, 40 Newton, then what will be the value of friction?
40.
Yes, and let's say the maximum limit of this surface is 50 Newton. I apply a force of 50 Newton, then also the friction will become 50 Newton. Now 50 Newton is the maximum value, that is the value of limiting friction. And if I apply a force, anything above 50, now this is my 60 Newton force. So what will be the friction now?
Then there is a net force between 10 newtons to the.
See, this time also the friction will be 50 Newton only, because the maximum value of static friction this surface can offer is 50 Newton. It cannot go a value higher than this. This is the maximum value of static friction. It's okay?
Yeah.
Okay, so if I increase the applied force further, let's say 70 Newton or 80 Newton or 100 Newton, the maximum value of limiting friction will be this one, isn't it? Now what if I apply 70 Newton force and once it starts moving, once it has started moving, now what will happen? Once it starts moving, the nature of the friction changes. From static friction to it comes to the kinetic friction because it has started moving, isn't it?
Yeah.
So it has started moving, the nature of the friction comes from static to kinetic friction, and we know the kinetic friction is always less than the static friction, isn't it?
Yeah.
This time if it starts moving, let's say now the friction can come down to even 30 Newton instead of being 50 Newton. Why this friction has reduced or it has become less? Just because we know, yes, we know every surface have irregularities on them. Every surface is having irregularities. Let's say there is one surface, it is having irregularities, another surface I am keeping on it, another, let's say I am block keeping on it, it will also have irregularities. These irregularities get interlocked. Because of the interlocking of these irregularities, this friction force is coming. There's an opposing force which is coming because of the interlocking of these irregularities. Now what happens? When this object starts moving? While it is moving, these irregularities get less time to get interlocked. Are you getting this thing? While it is moving, these irregularities get less time to get interlocked. The proper interlocking is not there. That's why the opposing force is reduced actually a little bit. And that's why the kinetic friction is less than the static friction. Is it clear?
Yeah.
Okay. So now, how you will find the value of friction force? Friction force is always how much? What is the formula for finding the friction force? Mu times friction force is mu times normal reaction, isn't it?
Yeah.
Mu times normal reaction. Let's say if the object is here, its mass is m, mg downward, this surface is on, yes, the motion of the object is constant in this direction, it cannot go in this direction. So the surface will offer a normal reaction on the opposite direction. And this normal reaction is equal to mg. So the friction becomes what? It becomes mu times mg. Okay, it is always mu times normal reaction. Normal reaction may be equal to mg, it may not be equal to mg, depending on the situation. Okay. So I think this much is clear. Now, if the object is at rest, it will be the coefficient. Now, this is known as coefficient of friction. You know this thing? Coefficient of friction. Okay. Now, if the object is at rest, they'll give you like this, mu k, that is coefficient of static friction, isn't it? This is mu times mu k, they write like this. This is known as coefficient of static friction if the object is at rest. Is it okay? Now, if the same object is moving, I'm writing it like this. This is coefficient of kinetic friction actually. When I'm writing K, kinetic friction. Okay. This is coefficient of kinetic friction. If I write mu s is what? Coefficient of static friction when the object is at rest. Is it okay?
Yeah.
Now one more thing I want to discuss over here. What is the relation between angle of friction and coefficient of friction? You know what is angle of friction? You know or you don't know? Okay, there is a relation between angle of friction and coefficient of friction. Let's try to find out what is angle of friction. I'm rubbing it, and let's draw a picture over here. Suppose an object is kept over here. Okay, any object which is kept over here. Basically, friction is the horizontal component of contact force. You know this? Suppose any surface is there. This, yes, this is any surface. On this surface, some block is kept like this. So this surface is going to what? Apply. This surface is going to apply forces like this. The forces can be in any direction, like this, isn't it? There will be like this. Let's say these are all contact forces. Contact forces. So let's say contact force will be in any direction like this, any direction like this. So when I draw this contact force, in this case, let's say this will be the contact force. Now this contact force will have two components, isn't it? Let's say this is the contact force. I'm drawing it. This contact force will have two components.